Hello, good afternoon. I'm Ryan Henning from Victoria Weather, and I'm here with my loyal assistant, Mariah the Weather Puppy, and we are going to teach you guys all a lesson about convection and the convective process that pretty much drives weather and life across planet Earth. Um, we talk about convection mostly in regards to thunderstorms, but it also is the process that develops all clouds, so rain showers, snow showers, and just the partly cloudy days that are so picturesque. What convection is it when you heat a lower level to the point that it is warmer than those above. As we all know, that warm air rises. That's why when there's a fire, you stay close to the ground, and if there's a fire in your house, for example, because the smoke is going to be heading towards the ceiling, or if you're at a campfire, the smoke is going upwards because the smoke is warmer than the ground or than the air around it. And that's a truism for the meteorological world as well. If a parcel, which is what we refer to as just a small, or could be fairly large portion of the atmosphere, gets warmer than the ambient air or the ideal conditions of the atmosphere around it, then it's going to start to rise. So for those purposes later, Mariah, who right now is a pretty dense parcel, is going to function as our atmospheric parcel, and then obviously the air around us is going to just be the atmosphere. But first I wanted to illustrate, not illustrate, but just describe exactly what it is that convection is. Like I said, it's when you heat a lower surface parcel, so it will lift with its warm energy northward. And the way you can do that, or the reason it works, is because warm air is denser than cold air. So as you increase temperature, the air particles in your parcel will move quicker, which means you can fit fewer of them in the particular parcel. So because there are fewer particles in this parcel, you have less weight. If you have fewer people in an elevator, the elevator isn't going to, or it's not going to be as heavy. And that's kind of the same concept. So if there's fewer particles of air in a parcel, it's going to be a lighter parcel. So it's less dense, and that means it's lighter. So if you heat something, then it's going to rise because it's lighter. Another way that you can make a parcel lighter or more unstable is to make it more humid. I know everybody, when it's a hot, sticky day, goes out there and they talk about how heavy the air feels, but in truth, it's actually lighter. If you look at a periodic table, a oxygen particle or atom has a atomic weight of 8, and a hydrogen particle has an atomic weight of 1. So if you put H2O, 2 hydrogen, 1 oxygen, you have an atomic weight of 10. Most of the air in the atmosphere is carbon dioxide, which is 2 oxygen, 1 carbon. And the 2 oxygen is 16. So on its own, that's already heavier than water. And then you add the carbon, which I believe is a 6. And you have air that's significantly heavier than water. And even if you just have oxygen, breathable oxygen, that's O2, and I already mentioned that that's going to be heavier than your water particles. So if you increase the humidity, that's going to make a parcel more unstable. Makes sense. So now we have either heated our parcel, or we have just made it less dense by making it moister. And I can tell you she just drank some water, so I think we're going to go with the Increased humidity, yeah, you. So sometimes in the heating of the day, you get what's called a cap, because the surface, or because of the ground, it's more difficult to change temperature. So it doesn't cool off as quickly at night, and it doesn't warm up as quickly during the day. So what the cap is the lower levels of the atmosphere are going to heat up more quickly than those very near the ground. So right now, if we've got a warmer lower atmosphere than our parcel, then she's going to lift and hit the cap and won't break through. But there's two ways you can break the cap. You can either increase the heating down here, or you can provide some forcing, like a cold front or a mountain range is a pretty good way to force air upwards. So if you have moving air, then that's great. But if you don't, say in the summer, especially in the southeast, if you don't have that forcing, you don't have really additional heating at the surface, and you don't have a trigger mechanism, you're not getting a cold front in South Georgia in the middle of July. You could just wait for the cap to break, and that could be, again, by just basic heating of the lower levels, or as the sun goes down, the angle to those lower levels of the atmosphere will decrease, so the atmosphere will cool rather than the surface warming up anymore. So then the cap breaks, and you're not hitting it, you're just getting a rising parcel. And once you get a rising parcel of air, especially warm, humid air, you're going to get more condensation and more precipitation, because a cooler parcel with lower pressure just can't hold as much precipitation. So you get clouds forming with condensing air, you get rain, you get thunderstorms, and depending on how fast the parcel is going to rise, that's how you're going to get the stronger showers and thunderstorms. In the colder temperatures, it holds less water, so that's why in the winter you get stratus, you get snow, and you don't see nearly as much precipitable water where you do in thunderstorms, because it takes a lot more to get those parcels to rise in the summer. But that pretty much summarizes how convection works, and why we, what the cap is, for example, and just how convection happens in our atmosphere. I obviously didn't rehearse this, so I'll rewatch it, and if I've got anything else to say, I will jump in with perhaps an additional video or a few words in a post. But for Victoria Weather, this has been your lesson on convection. I'm meteorologist Ryan Henning.